You clicked because you heard the AI boom is hitting a wall, and you are right to be concerned. The real problem is not that the software is failing, but that our century-old power grid is about to collapse under the weight of what it demands. By the end of this, you will understand why the next wave of artificial intelligence is not being stopped by algorithms, but by the physical inability of our electricity infrastructure to keep up. For years, the narrative has been simple. We built faster chips, wrote smarter code, and watched intelligence bloom. We treated data centers as passive consumers, like a factory that just needs a plug. But a major watchdog, the North American Electric Reliability Corporation, has issued its first formal alert that changes everything. They are no longer talking about software success stories. They are describing a physical infrastructure crisis. The issue is not that data centers are big. The issue is that they are behaving in ways that century-old grid assumptions simply cannot handle. Here is the thing that most people miss. In July of 2024, a single transmission fault in Northern Virginia caused 1.5 gigawatts of voltage-sensitive load to trip offline. To put that in perspective, that is the equivalent of a nuclear power plant suddenly shutting down. The grid operators saw the same collapse in load that they would see if a massive power source vanished. This was not a minor glitch. It was a wake-up call that data centers are no longer passive loads. They are large dynamic digital loads. They draw power with a speed and concentration that the legacy grid was never designed to support. Think of the power grid like a highway system built for steady, predictable traffic. You have cars moving at constant speeds and the flow is smooth. Data centers, however, are like 1,000 semi-trucks all merging onto the highway at the exact same time. They demand massive amounts of power instantly. When they ramp up, they create synchronized demand swings that stress the transfer capabilities of the grid. This causes congestion and voltage instability that traditional models cannot predict or prevent. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The scale of this shift is staggering. By 2030, U.S. data centers are projected to consume between 9 and 12% of the nation's total electricity. That is not just a lot of power. That is the equivalent of mid-sized cities drawing energy from the same wires. When you concentrate that much load in specific regions, you create a localized pressure cooker. The strain is not uniform across the country. It is concentrated in specific nodes where hyperscale campuses are built. This means regional power system stress is becoming the dominant failure mode for AI scaling. You can have the best algorithms in the world, but if the local grid cannot stabilize the voltage, the whole operation grinds to a halt. This creates a new bottleneck that has nothing to do with code. The primary constraint has shifted from compute availability to grid interconnection queues. Data center projects now face delays of 5 to 10 years just to secure new transmission lines. That is a hard timeline for an industry moving at the speed of software. You can train a model in weeks, but you cannot build the power infrastructure to run it in weeks. The industry is now pivoting from pure software optimization to a concept called co-design. This means data center siting, cooling systems, and power procurement must be engineered in lockstep with local grid capacity. It is no longer enough to just buy a server and plug it in. You have to understand the physics of the grid before you even lay a single brick. This brings us to the economic reality that is fundamentally altering the AI landscape. We are now facing what experts call the grid tax. The cost and timeline of securing power infrastructure now dictate the feasibility of new model training runs. Energy access has become the true gatekeeper of the next AI wave. If you cannot secure the power, the innovation stalls. This is not a theoretical risk. It is a hard constraint that is already shaping which companies can scale and which will be left behind. Now consider the stability risks introduced by these unique workloads. AI training runs are non-dispatchable. They require massive, continuous power for hours or days. When they ramp up, they can cause transient stability issues that legacy infrastructure cannot handle. The grid operators do not have real-time metrics to assess these transient events. They are flying blind, trying to manage a system that is changing faster than their monitoring tools can adapt. This lack of visibility means the crisis is currently defined by potential rather than widespread blackouts, but the potential for localized collapse is real. The nuance here is important. This is not a total system collapse waiting to happen everywhere. The evidence suggests that specific stability issues are often localized to regions with concentrated siting. However, without explicit co-design between compute and power infrastructure, the next wave of innovation will stall. The grid is the real constraint. It is the physical bottleneck that determines how fast the AI revolution can actually move. We are standing at a pivot point. The industry is moving away from the idea that software is the only thing that matters. The physical world is pushing back. The grid is the new frontier. Success will not belong to the company with the smartest code, but to the company that can solve the power puzzle. They must engineer their facilities to work with the grid, not against it. They must accept that the timeline for growth is now dictated by the speed of transmission line construction, not the speed of silicon fabrication. The question you should be asking is no longer about the next breakthrough in model architecture. It is about where the power will come from. The answer lies in how we integrate these massive digital loads into a fragile physical system. If we do not solve this, the AI boom will not be a bubble that bursts from overhype. It will be a wave that simply crashes against the shore of our infrastructure limits. The next phase of intelligence depends entirely on our ability to upgrade the grid to match the ambition of the software. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.